We're looking at indices, and we are quite familiar with this topic in mathematics. Index is actually the plural form of the word index. Now, index itself is a form of expressing large numbers in mathematics. So if you have a number like 1000, it can be expressed as or written as 10 to the power of 3. In this case, 10 is the base, 3 is the index, or also called the power or exponent. But 10 here is our base. Now, this number 1000, which is a large number, is written in this form. Now let's cut something. If you want to multiply 1000 times 1000, of course we're going to have 1 million, that's 6 zeros. Now this number 1000, which could be written as 10 to the power of 3, multiplied by another 1000, which is written as 10 to the power of 3 in indices, we're going to learn how to solve problems like this. Numbers that are in this index form, how do we solve them? Now, since they have a common base, we take out one of the base and add up our powers, or the index, 3 plus 3, which will still give us 10 to the power of 6, which is the same as our 1 million. So this brings us to the first law of indices, which is called the multiplication law. Multiplication law is our first law of indices. So from this, we now know that there are several laws of indices which will help us or guide us in solving problems that are usually in this form. So this multiplication law states that basically if we have to multiply two numbers that are in their index form, let's say x to the power of a times x to the power of b, where x and x here could represent numbers, the powers here also represent numbers. Now, this law states that as long as the bases are the same, we pick out one base and add up our powers. So if you have a number like 1 million times 1 million, instead of you to just start multiplying 1 million times 1 million, you can express it in this indices form. So we have 10 to the power of 6 times 10 to the power of 6, which will now give us 10 to the power of 12. Simple and interesting. So that's our first law. But remember, the law holds as long as our bases are the same. So, another example can have 2 to the power of, let's say, 3 times 2 to the power of 4. This can be written as 2 to the power of course, the bases are the same, so you pick out one of the base and add up our powers, 3 plus 4, which is 2 to the power of 7. Beautiful, you get your answer. Instead of expressing this 2 to the power of 3, of course, you know that will give us 8. 2 to the power of 4 will give us 16. Instead of multiplying 8 by 16, you can just express it in this form and find out your value. So now, but let's look at the situation where you have 2 to the power of 3 times, let's say, 3 to the power of 2. Can our law hold? No, it won't hold because the bases are not the same. So you can't say, because the bases are not the same, you say, okay, let's say to be 2 times 3 raised to the power of 3 plus 2, and you say maybe this is 6 to the power of 5. This answer is wrong because if we look at this 2 to the power of 3, let me show you something here. If we look at this 2 to the power of 3, 2 to the power of 3 is equal to 8, and 2 to the power of 2 is equal to 9. Of course, 8 is gotten from making this 2 in 3 places. That's 2 to the power of 3 is 2 times 2 times 2, 2 times 2, 4, 4 times 2, which gives us our 8. And 2 to the power of 9, this is 3 times 3, which gives us our 9. Now, if we are going to multiply 8 times 9, the product of 8 and 9 will not be the same thing as 6 to the power of 5. So, you can't say, because they don't have the same basis, you just multiply them out. No. Why I'm emphasizing on this is because it is very necessary and important that the law holds only if they have the same basis. If they have different bases, the law doesn't hold. And you can't assume and say, let me multiply and add up our powers. You get the answer wrong. So let's look at some more examples on multiplication law of indices. More examples that will help us understand it better. So if you have something like 2x raised to the power of 3 times y raised to the power of 2 times 3x raised to the power of minus, let me say 4 times y raised to the power of 5. I want to multiply this. Of course, looking at these numbers or terms here, they are expressed in index form. X raised to the power of 3, y raised to the power of 2, x raised to the power of 4, y raised to the power of 5. Now, based on our law, of course, we know that x and x here, they have the same basis, so we can simplify them out and write 2x raised to the power of 3 times 3x raised to the power of 4 times y raised to the power of 2 times y raised to the power of 5. I just collected my like terms. And I consider this and this. These 2 and 3, they are not the same. So I can write 2 times 3. And my x here and x here are the same. So I write times, let's say, x raised to the power of what? We add the powers, 3 plus 4. Times. Here, the bases are the same. Y raised to the power of 2 plus 5. So 2 times 3 is 6. X raised to the power of 7. Y raised to the power of 7. This is my answer for this. So what I've done here is I group my like terms. Consider the fact that my x is here, the same base with the same power. But these numbers are not in index form. I just multiply them out on their own. Pick out my x, single out the base, and add up the powers. Then I have my y raised to the power of 2 plus 5. The reason why I brought up this example is sometimes you might have issues like this or situations like this, which, okay, we're going to look at it. Is this really an index form? Yeah, of course, these are in their index form. So, but then secondly, we have some like terms. Can we group them? Yeah, we'll group this and this, group this and this, then we'll get our result. So that's one of the examples in terms of multiplication law. Remember, we are multiplying our index form, our indices, we are multiplying them out. So that's why the law has to do. So basically, in multiplication law, if you have two indices having the same base, multiplying themselves, pick out the single base and add up our parts. That's all about multiplication law. So let's look at another example that is a bit different from this. Let me say I have something like x raised to the power of 1 over 2 times x raised to the power of 2 over 3. Can my law hold here? Yes, of course it can hold. This is my base, these are the powers. But these powers are in fractional form. So we see singular are 1 base, add up our powers, 1 over 2 plus 2 over 3. I'm getting somewhere. So come up, x raised to the power. How do we add up fractions? Find the LCM of the denominator. Let's do it somewhere here. So half plus 2 over 3. We don't say 1 plus 2 is 3, 2 plus 3 is 5. Now in fraction addition, LCM of 2 and 3 is 6. 2 into 6, 3. 3 times 1, 3. Plus 3 into 6, 2. 2 times 2, 4. So my answer is 7 over 6. So I now write x raised to the power of 7 over 6. Very beautiful. So it's quite simple. It's just a way of playing with numbers that are in this form, considering the fact that they have the same base. Just take out the singular base, add up the parts. You can solve as many examples as possible. Alright, so next we're going to be looking at the division law.